So, what might this standardization look like for a building energy efficiency project? Whether this is for a new building or an existing building renovation, the process is the same. First, you have to set a baseline, using data and analysis to determine the baseline or minimum requirement that would be used without the energy efficiency project being funded. Second, savings projections, applying data and analysis to calculate the potential benefits that are achieved by funding the energy efficiency project. Next, design, construction, and verification. The design and construction phases of the project, and verifying or commissioning the building to ensure that it will operate as it was designed to operate. Operations, maintenance, and monitoring. The operational phase of the building after the construction is complete, where maintenance and monitoring are needed to ensure continued operation as it was intended to operate. Measurement and verification, continuous evaluation of the performance of the building. Let's go through each of these to see how project standardization can be used at each of these steps to increase investor confidence and enable project financing. First, how do we set a baseline or benchmark that can increase the confidence of investors? A baseline should be calculated to provide a reference for the energy use of the building without the implementation of the energy efficiency measures. This baseline should be based on an annual energy consumption analysis that accounts for weather and occupancy patterns and can be used to identify the life cycle energy consumption of the building in both the baseline and upgraded case. These data should be analyzed at the end-use level, such as at the level of space heating and cooling, ventilation, water heating, lighting, cooking, refrigeration, and so on. Next is to estimate the energy use of the building with the energy efficiency measures through the same calculation method and determine the energy savings that can be achieved by applying certain measures. In this process, it's important to have a certified energy modeling software and to know if the energy modeler is qualified to conduct the analysis. The energy modeling should also have consistent use of model files and calibration to ensure consistency and quality. In the energy analysis, the results from the energy modeling should be compared to key benchmarks to understand how good the savings are, and then to have those results displayed for the individual measures and also packaged for the entire project. Once the project is agreed on, the design and construction phases can begin. But the project standardization needs to continue throughout this process to ensure that the project will be understood through the sale and occupancy phases and to enable investor confidence. These are the stages where the rubber hits the road, and the construction team needs to ensure that the building plan becomes a reality, including the energy efficiency performance. This should be done with a series of inspections, measurements, and data logging to have the data needed that will enable an effective commissioning, which is done to ensure that the building is operating as it was designed to operate. From this process, a series of tools can be created for when the building is handed over to the operational phase. This includes having the operation performance verification plan from the commissioning process that can be used for retro commissioning and maintenance throughout the operational phase of the building. This can also result in a systems manual that indicates how to operate the building efficiently and training that allows the information to be absorbed by the team operating the building. The way that buildings are operated and maintained impact their energy performance. And monitoring this information is key to performance guarantees. The standardized approach must continue into the operational phase to enable investor confidence and to ensure that the building operates at a high performance level. This includes having an operations, maintenance, and monitoring plan, management approach, and process that includes a range of inspections and commissioning that will keep the building's performance on track. The operations manual and continued training can support capacity building of the staff and consistency in the approach. Each of the previous steps can enable improved measurement and verification and increase the likelihood that the building will perform as it was intended to. Proper measurement and verification procedures validate the reliability and effectiveness of predicted energy savings. The measurement and verification step is the full evaluation of that process and should be conducted by a credible evaluator. The results of the evaluation of the energy-efficient building should be documented in a report. This report could document the whole building or retrofit in isolation and could use utility bill analysis to understand the energy consumption over time. So when we think about this standardized approach, we need to understand what it does and does not do. The standardized approach does not invent new standards. It does not attempt to impose national standards in another country. It does not restrict engineering solutions. And it doesn't define a set level of energy savings. Instead, the standardized approach does, in the near term, increase deal flow, or the ability to match funders with those that need funding for energy-efficient buildings. In the long term, it also reduces risk and costs, which can reduce the cost of capital and attract more investors.